Hello and welcome to the KISSsoft video tutorial for bevel and hybrid gears. In the next 15 minutes I will show you about geometry calculation of bevel and hybrid gears, then strength calculation, then design functionalities of KISSsoft, fine and rough sizing functionalities, the contact analysis, and then also processes means 3D models and 5-axis milling for bevel gears. I will start with bevel and hybrid geometry. First of all, I would like to show you there are many examples of bevel and hybrid gears in KISSsoft available. These have many types of bevel gears inside. So we can have a look at the Klingelberg bevel gears. Then we also have Gleason face milling bevel gears in KISSsoft. And last but not least, we also have straight bevel gears, as they are typically used for differential bevel gears. Also these types, they can be calculated with KISSsoft. First of all, in the geometry, the designer defines about the type of bevel gear. It means, is it a standard type which is used for straight bevel gears? Is it a Gleason type or a Klingelberg type? And these different bevel gear types, they can be selected in this list. Also, if there is an existing bevel gear design from Gleason and a Gleason dimension sheet is available, it's very comfortable to add the bevel gear design, the existing design, by the conversion functionalities. These data, they are typically given in a Gleason dimension sheet of a face milling bevel gear set, and it makes it very easy to enter these data and then to transform it into the KISSsoft calculation. Other typical data for geometry calculation, they are given here in the geometry window. As you can see, it's spiral angle, but also addendum and dedendum angle of the bevel gear. Then also tooth thickness modification coefficient and offset. These geometrical data, they can be given in basic data. Also for bevel gear, manufacturing data are imported. It means the size of cutter head, and here we can see this current design is a Gleason face milling design, and so in the list information, in the information graph, we can see the typically available cutter head sizes as they are given in the ISO 23509. The same happens actually if it is a Klingelberg design. The Klingelberg design, it's per default, its face hobbing is active, and in the information graph there are the typical available cutter heads from Klingelberg. They are listed, and it makes it easy to get a cutter head which is suitable to get it very quickly. So we can define also manually the cutter radius and number of blade groups if this is maybe a special cutter head design. In the tab reference profile data. The coefficients are given for root, didendum and addendum coefficients as they are defined in the ISO standard as well. Tolerances are important. Tolerances are about tooth thickness and backlash. However, for the bevel gear, it's very common to have no backlash actually defined as the gear and actually not defined in the manufacturing profile shift system. Typically, backlash is defined by either the tooth thickness modification coefficient or only in the assembling. It means the ring gear is just retracted a little bit by the amount of required backlash. So these are the calculation for geometry. I will continue now with ratings. In the tab ratings there are many standards available for strength rating, starting with 2 static calculation. As typically differential bevel gears, they are applied in a static mode. But then also the ISO calculations are available in KISSsoft, AGMA, DIN, Klingelberg, then Det Norske Veritas for marine transmissions and hypoid gear calculations. Beside root and flank strength calculation, also scuffing can be calculated according to the ISO TR or the DIN standard. Also, tooth flank fracture is a very actual topic. Also there in KISSsoft there are several methods are available which can be taken for tooth flank fracture rating. Also in KISSsoft it's possible to apply a load spectra. This can be done either by a predefined load spectra or by an own input if you want to add own values which you just want to define within that calculation. In the tab factors there are special factors given or available for modification. Typically the mounting factor is one of a typically modified factor as it defines the KH beta, defined then on the type of assembly or the type of testing. In the bevel gear design there are 2 functionalities from KISSsoft provided. It's the rough sizing and it's the fine sizing. Rough sizing gives a first initial design based on some data which are given by specifications. So the user enters a ratio, he enters the face width to mean normal module ratio and the ratio of outer cone distance to face width and the spiral angle, and then he will get a proposal from the software which is actually reasonable. He can overtake it and he gets a very first and a very quick first design. The fine sizing of bevel gear actually is a variation of design parameters. So let's have an example. Let's keep the outer pitch diameter of the ring gear as constant, but let's see for other solutions having a different spiral angle, maybe starting from 20 to 40 degrees. with a step width of 2 degrees, and let's vary also the number of teeth for the pinion between 11 and 24. Calculating all these variants, it will give a number of solutions, maybe a big number of solutions, which will show then to the designer which is the best or the optimized macro geometry for his design. In that case, in very short time, 822 solutions are found. The results can be checked either by a list or graphically, and the parameters for evaluation typically are for a x-axis are strength, or actually any design criteria, and typically for the color scale it's a design parameter. In that case it's mean normal module, but it could also be number of teeth for pinion, just to find out which number of teeth, here higher number, or actually these are the lower number, to find some tendencies in the design for best flank safety or for best root safety. This is the fine sizing functionality from KISSsoft, helping to get best designs. I will continue now to contact analysis. Contact analysis actually will give a rating of the applied modifications. As you may know, bevel gears typically have a lengthwise crowning in order to avoid the edge contacts on the load. So also in contact analysis it has to be determined about the misalignment V, H and J, as where in Gleason terminology it's called E, P and G. In this case I just have the value 0, and I will do a contact analysis of this design. So let me maybe take an initial design from a sample, as I was taking some values maybe different than the sample will do. So, and now I can check the results of contact analysis. Typically this is the contact pattern on the ring gear. I can see the distribution of the contact. It looks quite nice as it is now. Then I can also check about transmission error. Transmission error is an indication for noise. I can also check about scuffing results. I can check about stress curve in 3D. So these are evaluations which help the designer to get the best possible crowning on the tooth flank, to have a good balance between an insensitivity of the contact but also an optimized final design. Now I will continue with 3D models and processes. For manufacturing, typically Gleason and Klingelberg machine equipment is used for a mid-size of batch or a big size of batches. So for high volumes, definitely these machines, they are typically applied. For small batches or maybe spare parts manufacturing, 5-axis milling is established as well, as it is much more flexible. In order to have 3D models for 5-axis milling, KISSsoft will provide the 3D models and these can be saved and individually for pinion and for ring gear, and this can be used then finally for the CAM software. Also for quality checks, the measurement grid data can be calculated. So the measurement machine, it can be chosen between Klingelberg and Gleason format, and when the measurement grid is calculated and saved, it can be used then for any of these machines, and with that data the measurement of the 3D models, the manufactured on 5-axis milling machines, can be done. This was about bevel and hyperbead gear calculation in KISSsoft. If you have any questions about any more details in bevel and hyperbead gear design, please don't hesitate to come back to KISSsoft and ask for detailed instructions or any more tutorials. Thank you for your attention.